So in this video, we're going to look at how to solve by graphing. And so we're going to actually do the graphing and find that solution. And so in this particular one, we've got two equations, 2x plus y equals -4 and x minus y equals -8. So in order to graph these, we're going to do one at a time. This first one here, we're going to come down. We need to have y by itself, so we need to subtract 2x from both sides. So that's going to give us y equals -2x minus 4. And so on this one, our y-intercept is -4, so we're going to plot that. 1, 2, 3, 4. Hopefully you all remember how to do this from last semester. And then our slope is -2/1, so we're going to go down 2 and right 1. And for this, because I want to know exactly where these two lines are going to cross, I'm going to go ahead and plot every single point I can fit on this graph. So remember, -2/1 means we can go down 2, right 1, or we can go up 2, left 1. So I'm going to do that to finish off the rest of my points. And I'm going to do this because this way I won't make that mistake that I made on the juice problem in the last video. I'm going to have every single point represented there. So I've got all of those points, and so now I can draw my line through all of those. So there's the first one. Now let's graph this. Let's graph the second one. It is x minus y equals -8, and so we need to get the y by itself. So I'm going to rewrite this one down here. We want y by itself, so we're going to subtract x. So -y equals -x minus 8. And then we want y by itself, so we're going to divide everything by -1. So y equals x plus 8. So we have a y-intercept here of 8, so we're going to go up there. 1, 2, 3, 4, 5, 6, 7, 8. And our slope is 1, or 1/1. So we can go up 1, right 1. And to go the other way, we can go down 1, left 1. And I'm going to keep doing that until I get to the part right there where I cross that line. And so now I'm going to draw, and I don't need to keep going because I already know right here is where those two lines are crossing. So I'm going to go ahead and draw that line. And so this point right here is the point. Let's see, here's our origin. 1, 2, 3, 4, -4. 1, 2, 3, 4. It looks like -4, 4. But we always want to check our solution just to make sure. So let's double check. We've got 2 times -4 plus 4 should equal -4. 2 times -4 is -8 plus 4, -4 does equal -4. So it checks out in that one. And now let's try this one. We're going to have -4 minus y is 4 equals -8. -4 minus 4 is -8. Oops. Well, I need one there, not an equal sign. -8 does equal -8. It checks out there, which means -4, 4 is our solution. So let's take a look at another one. We've got this one right here. Sorry, my little helper here is covering up my pages. Okay, so we're going to solve same directions here. We've got two different equations here, and this one right here, a lot of you are probably looking at that and cringing because it's got all these fractions in here. Well, let me show you a real easy way to get rid of all of those fractions. Notice they all have a denominator of 5, and so we can do what's called clearing the fraction, and we've done this a little bit here and there. We can multiply everything here by 5. And so when we distribute then this 5, 1/5 times 5 is 1, so we're left with 1x. Minus 2/5 times 5 is 2, 2y. And then 8/5 times 5 is 8, so that's going to equal a -8. And so now we can rearrange this to get the y by itself. So we're going to subtract x, so -2y equals -x minus 8. Divide everything by -2. So y equals -1 over -2 is positive 1/2 x. -8 divided by -2 is positive 4. So we've got a y-intercept of 4, 1, 2, 3, 4, and a slope of 1/2. So we're going to go up 1 over 2. We're going to go up 1 over 2, up 1 over 2, up 1 over 2. So we've got it all that way. We can also go down 1, left 2. Down one, left two, and one more there. And now we can draw the line connecting all of those points. Again, I drew all of those so I can just help ensure exactly where these two lines are going to cross. Now this one here is a little bit more simple. We want y by itself, so we're going to add 3/4 x to both sides. So that's going to give us y equals positive 3/4 x plus 3. So our y-intercept here is positive 3, so it's right there. And then we're going to go up 3, 1, 2, 3, and to the right 4, 1, 2, 3, 4, right there. And then we can do it one more time, up 1, 2, 3, and to the right 1, 2, 3, 4. And these two lines are going to be very close to each other. Okay, so we're going to go ahead and draw the line connecting those dots here. And we had already seen that those two lines shared this point right there. So let's see what point that is. We've got 1, 2, 3, 4. So it's 4, comma, 1, 2, 3, 4, 5, 6. So it's the point 4, 6. And again, we need to check our solution. So we're going to plug this back in. Now, this right here, I don't like this, all these fractions, so I'm not going to use this version. I'm going to use this version. Okay, sorry about that. My little helper got a little curious there. So anyway, we've got the point 4, 6, which is where we think these two lines are crossing. This equation right here is not so pretty because of all those fractions, but if we look here, this is an equivalent equation. Remember, we talked about those last semester because we multiplied everything by 5. So I'm going to check this point 4, 6 in this form of the equation. And so we've got x is 4, y is 6, so we have 4 minus 2 times 6 should equal negative 8. Negative 2 times 6 is negative 12, so 4 minus 12 equals negative 8. 4 minus 12 is negative 8, so that one checks out. Now let's try this one. Negative 3/4 times 4 plus 6 should equal 3. Well, negative 3/4 times 4 is just negative 3 plus 6 should equal 3. Negative 3 plus 6 is 3. 3 does equal 3, so it checks out in that one. So our solution here is 4, 6. Now the last one we're going to do here, we have the system y equals 3 and y equals 2x minus 7. So y equals 3, you should recognize that as a special type of line. There's only one variable, a y, which tells us that this is either what? A horizontal or a vertical line. And now how do we decide which one it is? Well, remember that if it only has a y, the letter that they give us is the axis that it's going through. So it's going through the y-axis at 3, which means it's a horizontal line at 3. So a y-intercept would be 3, and it would be going straight across here. And so this one, because I know it's straight across here, all these x values of 3, I don't need to put all of those points. And now let's do this one, y equals 2x minus 7. It's already in slope-intercept form, so I can go ahead and plot my y-intercept of negative 7. 1, 2, 3, 4, 5, 6, 7. And my slope is 2, or 2 over 1. So I'm going to go up 2, 1, 2 over 1. And I'm going to keep doing that until I run into that other line. 2 over 1, and right there is where it happens. So let's go ahead and draw that line all the way across the graph. And right here is the point where those two lines are crossing, it looks like. So let's check. So that point would be 1, 2, 3, 4, 5, comma, 3. And we need to check that. Well, how do we check it in here? Well, there is no x to plug the 5. There's the 3 is the y, so 3 equals 3. Well, that, of course, checks out. And then over here, y is 3. 3 should equal 2 times x is 5 minus 7. So does 3 equal 10 minus 7? 10 minus 7 is 3. So 3 does equal 3. Sorry, I got off the graph there for a minute, or off the page. And so this one checks out. So our solution here is 5, 3. So again, most important thing on these is to graph your lines, of course, correctly. Draw all of the points that you can fit on the graph use a ruler or some other straight edge to draw those lines, and then check your solution. When you think you know the 2 points or the 1 point where those two lines cross, substitute that XY combination back into both equations to double check.